The planet Saturn. In the silent depths of the cosmos, far beyond the orbit of Earth and the warmth of our familiar sun, lies a world that defies imagination, a giant adorned with shimmering rings, a planet so majestic that even the most hardened astronomers of history could not gaze upon it without awe. This is Saturn, the jewel of our solar system, a celestial masterpiece that has fascinated humanity for centuries. Unlike any other planet, Saturn is not only a massive world of gas and storms, but also a symbol of mystery and grandeur. Its rings glisten like a cosmic crown, stretching wide into space, whispering stories of creation, destruction, and time itself. To speak of Saturn is to step into an endless narrative where science and wonder intertwine, a tale where every discovery leads to deeper questions and every observation sparks new awe. Saturn is not just a planet, it is a stage where the drama of the universe unfolds, with moons as actors, rings as curtains, and the planet itself as the timeless protagonist. Human beings have always been drawn to the extraordinary. When our ancestors first turned their eyes to the night sky, Saturn stood out as one of the brightest wandering stars, glowing like a pale golden lantern against the velvet blackness. To the naked eye, it was simply a point of light, but its steady glow carried an unshakable allure. Through telescopes, however, Saturn revealed its true nature, an otherworldly giant encircled by rings of ice and rock, unlike anything else seen in the heavens. Galileo Galilei, when he first pointed his primitive telescope toward Saturn in 1610, could not even fully comprehend what he saw. To him, Saturn appeared to have ears, or perhaps two smaller planets flanking its sides. Only later, with more powerful instruments, did humanity uncover the magnificent rings that now define Saturn in both science and imagination. But Saturn is far more than its famous adornments. It is a colossus, the second largest planet in our solar system, made mostly of hydrogen and helium, with storms so vast they could engulf our entire world. Its atmosphere is a swirling tapestry of clouds, winds, and hexagonal mysteries at its poles. Its magnetic field stretches far into space, trapping particles and shaping the environment around it. And then there are its moons, over 80 of them discovered so far, each a world in its own right. Titan, with its orange skies and lakes of methane, could easily be mistaken for a strange cousin of Earth. Enceladus, gleaming and icy, sprays plumes of water into space, hinting at a hidden ocean that might harbor life. Together, Saturn and its moons form a miniature solar system, a vast laboratory for cosmic exploration. In mythology, Saturn was the Roman god of time, wealth, and harvest, often depicted as an ancient figure with a scythe, endlessly linked with cycles of creation and destruction. How fitting, then, that the planet named after him embodies those same eternal cycles, rings created from shattered moons, storms that rage and then fade, ice and rock forever dancing around an ancient world. Saturn is not static, it is alive, changing and evolving. To study Saturn is to study time itself, to look back into the history of our solar system, and perhaps to glimpse its future. The story of Saturn is not only a scientific one, it is also deeply human. Each mission that has ventured toward it, from Pioneer and Voyager to the legendary Cassini-Huygens mission, has carried with it the dreams of generations. Through the eyes of these spacecraft, we have watched the rings in dazzling detail, flown past icy moons, and even dropped a probe into Titan's thick orange atmosphere, landing on a world billions of kilometers away. These journeys have expanded not just our knowledge, but our imagination, reminding us of how small we are in the vastness of space and how boundless our curiosity can be. As we begin this exploration of Saturn, let us journey step by step into its wonders. We will dive into its composition, study its storms, marvel at its rings, and voyage to its moons. We will trace the footsteps of astronomers who first discovered its secrets and follow the paths of spacecraft that revealed it in all its glory. Saturn is not just a planet, it is a story that has been unfolding for billions of years, waiting for us to read it, chapter by chapter. To truly understand Saturn, One must first grasp its scale, for size alone sets it apart as one of the most dominant members of our solar system. Saturn is the second largest planet, dwarfed only by Jupiter, yet still enormous beyond human imagination. Its equatorial diameter stretches about 120,536 kilometers, more than 9 times the width of Earth. If Earth were the size of a small marble, Saturn would be a beach ball towering over it. Its volume is so vast that over 760 Earths could fit comfortably inside, and yet, for all its size, Saturn is a planet of paradoxes, a giant both mighty and fragile. Unlike Earth, Saturn has no solid surface. It is a gas giant, composed primarily of hydrogen, about 96%, and helium, around 3%. These are the same primordial elements that formed our Sun, making Saturn a sibling in composition to the star at the center of our solar system. Its density, however, is astonishingly low, only 0.687 grams per cubic centimeter, less than water. This means that if there were a cosmic ocean large enough to hold it, Saturn would float. No other planet in the solar system shares this strange trait so dramatically. Saturn's lightness is deceptive, though, for its gravitational pull is immense. Despite its low density, Saturn's mass is about 95 times that of Earth, making it a true heavyweight of the planetary family. The structure of Saturn can be imagined in layers, each one descending deeper into the giant's hidden heart. At the top lies the atmosphere, a delicate haze of hydrogen and helium laced with trace gases like methane and ammonia. Beneath this airy exterior, pressures increase drastically, transforming gases into exotic states. Hydrogen, under the crushing weight of Saturn's gravity, transitions from a gaseous form into a liquid and eventually into a metallic state, an ocean of liquid metallic hydrogen surrounding the core. This strange substance, unknown on Earth, conducts electricity and is thought to play a vital role in generating Saturn's magnetic field. Deep within lies the mysterious core itself, perhaps a dense mix of rock, metal, and ices, weighing 10 to 20 times the mass of Earth. Yet no probe has ever reached it, and no human eye has seen it. The heart of Saturn remains a hidden secret. The atmosphere of Saturn is a realm of perpetual storms, a theater where winds, clouds, and turbulence perform an endless ballet. Saturn's winds are among the fastest in the solar system, reaching speeds up to 1,800 kilometers per hour near the equator. These gales whip the clouds into bands of alternating colors, pale yellows and golds, stretched around the planet's girth. Unlike Jupiter's bold stripes, Saturn's bands are more subdued, their subtlety owed in part to the thicker haze in its upper atmosphere. But make no mistake, behind their gentle appearance lies raw power. One of Saturn's most iconic atmospheric features is the mysterious hexagon at its north pole. This massive, six-sided storm, first discovered by the Voyager spacecraft and later studied in detail by Cassini, is unlike anything seen elsewhere in the solar system. The hexagon is vast, about 30,000 kilometers across, wide enough to fit 4 Earths inside, and it rotates steadily, maintaining its shape with uncanny stability. Scientists believe it is a result of atmospheric waves interacting with jet streams, but its precise origins remain debated. To gaze upon the hexagon is to confront the strange, almost alien geometry of nature itself. Storms on Saturn are not confined to its poles. From time to time, the planet erupts with tempests so enormous they encircle its entire circumference. Known as Great White Spots, these storms appear roughly once every Saturnian year, about 30 Earth years. They are titanic eruptions of energy, creating bright, turbulent clouds that can last for months. The most recent Great White Spot observed in 2010 gave scientists a front-row seat to the chaos of Saturn's atmosphere, revealing how heat and convection drive its weather systems. These storms are reminders that beneath Saturn's serene beauty lies a restless, violent world. The interplay of light and shadow on Saturn adds another layer of wonder. Because of its great distance from the Sun, about 1.4 billion kilometers away, sunlight is weaker there, only about 1% as strong as what Earth receives. Yet Saturn reflects this light in a soft golden hue, a glow that has captivated observers for centuries. The planet's upper atmosphere is filled with hazes and small particles that scatter sunlight, giving Saturn its pale, muted colors, like a watercolor painting suspended in the void. Saturn's magnetic field, generated by its rotating metallic hydrogen interior, is another defining characteristic. Though weaker than Jupiter's, Saturn's magnetosphere still extends hundreds of thousands of kilometers into space, enveloping the planet, its rings, and many of its moons. This invisible shield traps charged particles and interacts with the solar wind, creating dazzling auroras at Saturn's poles. These auroras, captured in ultraviolet by the Hubble Space Telescope and in infrared by Cassini, flicker with ghostly light, painting Saturn's skies with a beauty rivaling Earth's northern and southern lights. When we look at Saturn, we are not seeing a static object but a dynamic world of physics and chemistry. Every storm, every wind current, and every shift in its magnetic field tells us more about the fundamental processes that shape not just Saturn but gas giants across the universe. By studying Saturn's structure and atmosphere, scientists gain insight into the very nature of planetary formation, the balance between gravity and pressure, and the forces that sculpt worlds. Saturn's sheer size, composition, and storms set the stage for the wonders yet to come. But to truly grasp why this planet holds such a central place in our imagination, one must turn to its most breathtaking feature, the rings. These delicate, shimmering bands of ice and dust transform Saturn from a giant into a masterpiece, making it the most visually spectacular planet in the solar system. If Saturn is the crown jewel of our solar system, then its rings are the sparkling diamonds that make it shine. No feature in our planetary neighborhood is more iconic, more breathtaking, or more mysterious than the rings of Saturn. They transform the planet from a simple gas giant into a cosmic masterpiece, a work of art painted across the black canvas of space. To see Saturn through a telescope, even a small one, is to be struck with awe, a glowing golden sphere wrapped in luminous bands that appear too delicate, too beautiful to be real. And yet, they are real, an immense structure stretching hundreds of thousands of kilometers across, encircling the planet like a celestial halo. At first glance, the rings may appear solid, like giant discs cut from shining ice or metal. But closer study reveals a more complex truth. Saturn's rings are made of billions of tiny particles, ranging from dust grains smaller than a speck of sand to boulders the size of houses, and perhaps even chunks as large as mountains. These countless pieces, mostly composed of water ice with traces of rock, orbit Saturn in perfect harmony, each one obeying the laws of gravity and motion. Together, they form a vast, shimmering disk that can be over 280,000 kilometers wide, nearly three-quarters the distance from Earth to the Moon, yet astonishingly thin, only about 10 meters thick in some places. To put it in perspective, if Saturn's rings were scaled down to the thickness of a sheet of paper, they would stretch across an entire football field. Astronomers divide the rings into several main sections, labeled with letters in the order of their discovery rather than their actual position. The brightest and most prominent are the A, B, and C rings, separated by gaps such as the Cassini division, a dark band named after Giovanni Domenico Cassini, who first described it in 1675. Beyond these lie the faint D ring, the outer E and G rings, and the diffuse F ring, which is twisted and sculpted by the gravitational pull of nearby shepherd moons. Each ring has its own texture, density, and mysteries, and together they form a system as intricate and varied as any planetary surface. The question of how Saturn's rings formed remains one of the great puzzles of planetary science. Some scientists believe they are ancient, perhaps remnants from the early solar system, made of leftover material that never coalesced into a moon. Others argue they are relatively young, no more than a few 100 million years old, formed when a moon or comet ventured too close to Saturn and was torn apart by tidal forces. Evidence from the Cassini spacecraft suggests the rings may indeed be younger than once thought, their ice too bright and pristine to have survived billions of years without darkening from cosmic dust. If true, then humanity may be witnessing Saturn in a special, temporary phase of its life, adorned with rings that one day may vanish. The physics behind the rings is as fascinating as their beauty. Each particle orbits Saturn at its own speed, faster closer to the planet and slower farther away, in accordance with Kepler's laws. Collisions among particles are constant, but usually gentle, allowing them to settle into thin, flat plains. Moons both large and small play a vital role in shaping the rings. Tiny shepherd moons like Prometheus and Pandora act like cosmic gardeners, pulling and tugging at the edges of the F-ring, creating ripples and braids. Larger moons, such as Mimas, exert gravitational influences that carve out gaps and divisions, like the Cassini division itself. In this way, the rings are not static structures but living, dynamic systems, constantly shifting and evolving. One of the most intriguing aspects of Saturn's rings is their interaction with the planet itself. Cassini discovered that particles from the rings are gradually falling into Saturn's atmosphere, a process known as ring rain. This rain of icy material influences Saturn's atmosphere and may one day deplete the rings entirely. Over tens of millions of years, the brilliant crown that makes Saturn so unique could fade away, leaving the planet bare, indistinguishable from Jupiter to the naked eye. The thought is both humbling and profound. The beauty we marvel at today may be fleeting, a temporary jewel in the timeline of the cosmos. For humans, the rings have always carried symbolic power. To Galileo in 1610, they were a baffling anomaly. He described Saturn as having ears, unable to discern their true nature with his modest telescope. To Christian Huygens, using a more advanced telescope in 1655, they became a thin disk encircling the planet, a revolutionary concept at the time. To later astronomers, they became a subject of endless fascination, and to modern scientists, they are a natural laboratory for studying the mechanics of disks everywhere in the universe. The same physical principles that govern Saturn's rings also shape the disks of dust and gas around young stars, from which planets themselves are born. In studying Saturn's rings, we glimpse not only the beauty of a single planet, but the processes that built entire solar systems. The rings are also deeply tied to Saturn's moons, especially Titan and Enceladus, which contribute material to them. The E-ring, for instance, is sustained by geysers from Enceladus, which spray plumes of water ice into space, replenishing the ring with fresh material. This connection shows that Saturn's rings and moons are not separate entities, but parts of a single, interconnected system, bound together by gravity and exchange of matter. To look at Saturn's rings is to feel the vastness of time and space. They are at once fragile and eternal, simple in composition, yet complex in behavior. From a distance, they appear as a perfect, unbroken band of light. Up close, they reveal themselves as countless individuals moving in unison, like stars in a galaxy or dancers in a cosmic ballet. They remind us that beauty often arises from the simplest ingredients: ice, rock, gravity, and that order can emerge from chaos. Saturn's rings are not merely ornaments. They are storytellers, carrying within them the history of moons destroyed, comets captured, and forces unleashed. They are a window into Saturn's past and a clue to its future. Above all, they are a reminder of why we look to the skies in wonder, to see the universe not just as a mechanism of physics and chemistry, but as a canvas of sublime beauty. If Saturn's rings are its crown, then its moons are the jewels embedded within that crown, each unique, each mysterious, and each playing a role in the greater story of the planet. With more than 80 confirmed moons, Saturn possesses one of the largest and most varied satellite systems in our solar system. These moons range in size from tiny fragments of ice and rock only a few kilometers across, to massive worlds like Titan, which is larger than the planet Mercury. Together, they create a complex dance of orbits, resonances, and interactions, shaping not only themselves but also Saturn's rings and magnetic environment. To study Saturn's moons is to enter a gallery of worlds, each one a portrait of possibility. The most famous of Saturn's moons, and arguably the most intriguing in the entire solar system, is Titan. Discovered by Christian Huygens in 1655, Titan is a world so extraordinary that it seems almost like Earth's twin in disguise. At 5,150 kilometers in diameter, Titan is larger than Mercury and second only to Jupiter's Ganymede among the moons of our solar system. Yet what makes Titan so special is not its size but its atmosphere. Unlike most moons, which are airless and barren, Titan possesses a thick atmosphere rich in nitrogen, with a haze of methane and complex hydrocarbons. This atmosphere, denser even than Earth's, blankets Titan in an orange glow, making it the only moon where humans could technically walk on the surface without a pressure suit, though they would need oxygen to breathe and insulation against the bone-chilling cold. Titan is a world of extremes. Its surface temperature hovers around minus 179 degrees Celsius, minus 290 degrees Fahrenheit, cold enough for water to be as solid as rock. Instead, it is methane and ethane, hydrocarbons that are gases on Earth, that exist as liquids on Titan. Rivers and lakes of liquid methane carve valleys, flow into seas, and create landscapes eerily reminiscent of Earth. Cassini's radar images revealed vast lakes such as Kraken Mare, larger than all of Earth's Great Lakes combined. This means that Titan is not only the only other world in the solar system with stable surface liquids, but also a place where weather, clouds, rain, and storms occurs in a cycle parallel to Earth's water cycle, only with methane. The mysteries of Titan deepen with the Huygens probe, which landed on its surface in 2005 after being released from the Cassini spacecraft. For a few precious hours, Huygens transmitted images and data back to Earth, showing a pebbly landscape shaped by erosion, with channels carved by flowing liquids. It was the first landing ever achieved on a body in the outer solar system, and it gave humanity a glimpse of a world both alien and strangely familiar. Scientists now believe Titan may also hide an internal ocean of liquid water beneath its icy crust, making it a candidate for potential habitability. Titan is, in every sense, a world worthy of exploration, a bridge between the Earth we know and the alien worlds that await. If Titan is Saturn's enigmatic giant, then Enceladus is its shimmering jewel of mystery. Only about 500 kilometers across, small enough to fit inside the state of Arizona, Enceladus might seem unremarkable at first glance. But appearances deceive. Beneath its gleaming white surface of fresh ice lies an ocean that could harbor the ingredients for life. Enceladus first revealed its secret in 2005, when the Cassini spacecraft detected towering plumes of water vapor erupting from cracks near its south pole. These geysers spray hundreds of kilometers into space, replenishing Saturn's E-ring with fresh material and hinting at a vast subsurface ocean. Analysis of the plumes revealed not just water but also salts, organic molecules, and even hints of hydrothermal activity, conditions strikingly similar to Earth's deep ocean vents, where life thrives without sunlight. The discovery transformed Enceladus into one of the most exciting places in the search for extraterrestrial life. Though hidden beneath kilometers of ice, its ocean may be habitable, warmed by tidal forces from Saturn's gravity. To study Enceladus is to peer into a natural laboratory of astrobiology, where chemistry, water, and energy converge. Many scientists now dream of future missions that could fly through the plumes, sampling them for signs of microbial life. Among Saturn's smaller moons, Mimas stands out for its striking appearance. With a diameter of just 396 kilometers, Mimas might have gone unnoticed, if not for the enormous crater that dominates its surface. Known as Herschel Crater, this impact site is so large, relative to the Moon, that it gives Mimas the appearance of the Death Star from Star Wars. Despite its dramatic look, Mimas is a frozen, heavily cratered world, likely inactive. Yet it plays a role in shaping Saturn's rings, as its gravitational pull creates gaps and divisions within them, including the Cassini division itself. Another of Saturn's moons, Iapetus, is a study in contrasts. Half of its surface is bright as snow, while the other half is as dark as coal. This yin-yang appearance puzzled astronomers for centuries. Today, scientists believe the dark material comes from dust collected from outer moons, which, once settled, absorbs sunlight and causes more ice to sublimate, creating a runaway effect. Iapetus also features an enormous equatorial ridge, a chain of mountains that makes it look almost like a walnut. This ridge is unique in the solar system, and its origin remains debated, perhaps remnants of a collapsed ring or ancient tectonic activity. Beyond these, Saturn has many more moons: Rhea, Dione, Tethys, Hyperion, and countless smaller ones, each adding to the story. Rhea may have its own tenuous ring system. Hyperion tumbles chaotically as it orbits, a cosmic cork spinning unpredictably through space. Each moon is a reminder of Saturn's richness, a solar system in miniature where every world has a story. Together, Saturn's moons form a dynamic and interconnected family. They shape the rings, exchange material, and reveal possibilities for life beyond Earth. From Titan's methane seas to Enceladus's watery plumes, these moons remind us that Saturn is not just a planet but a realm of worlds, each a chapter in the grand saga of the cosmos. Long before telescopes revealed the rings, long before spacecraft ventured to the outer solar system, Saturn was already a figure of wonder to humanity. To the ancients, Saturn was more than just a distant light in the night sky. It was a god, a symbol, and a marker of time itself. Its slow movement across the heavens, its pale golden glow, and its remoteness from Earth gave it an aura of mystery and weight, ensuring it held a powerful place in mythologies across cultures. In Roman mythology, Saturn was the god of time, harvest, wealth, and renewal. He was depicted as an aged deity with a sickle, cutting both crops and, symbolically, the fabric of existence itself. The Romans celebrated him during the Festival of Saturnalia, a time of feasting, gift-giving, and reversal of social roles. During Saturnalia, slaves and masters would exchange positions, and the strict order of society was momentarily suspended, reflecting Saturn's association with cycles, change, and liberation. The Romans borrowed much of their mythology from the Greeks, where Saturn was equated with Cronus, the leader of the Titans. Cronus, fearing a prophecy that his children would overthrow him, devoured them one by one. Yet Zeus, saved in secret by his mother Rhea, ultimately defeated Cronus, fulfilling the prophecy. Thus Saturn/Cronus became a figure associated with cycles of destruction and rebirth, echoing the planetary Saturn's role in cosmic cycles of creation and decay, as seen in its rings and moons. The association of Saturn with time itself is fitting, for even astronomically, Saturn marks time in ways visible to the naked eye. Moving slowly across the sky, it takes nearly 30 years to complete one orbit of the Sun. In ancient cultures, this made Saturn the planet of long cycles, patience, and inevitability, the slow tick of a cosmic clock. In Babylonian astronomy, Saturn was associated with Ninurta, a god of war and agriculture. To the Chinese, it was linked with the element Earth and considered the planet of stability. In Hindu tradition, Saturn is known as Shani, a deity representing discipline, justice, and karma, believed to bring challenges and trials, but also growth and wisdom. Astrology across cultures often considered Saturn a planet of seriousness, limitation, and structure, a cosmic teacher who brings hardship but also maturity. This cultural significance shows how deeply Saturn's distant light touched human imagination. Without telescopes or spacecraft, people already intuited Saturn's association with time, struggle, and cycles, ideas we still find mirrored in scientific truths about the planet. The true revolution in humanity's understanding of Saturn began in the early 17th century with the invention of the telescope. In 1610, Galileo Galilei turned his telescope to Saturn and saw something so strange he could not describe it clearly. To him, Saturn appeared to have ears or handles. His telescope lacked the resolution to reveal the rings, so he concluded Saturn might have two smaller bodies attached to its sides. Later, when the rings were tilted edge-on to Earth and seemed to disappear, Galileo was even more baffled, wondering if Saturn had swallowed its children, like the god Cronus of myth. It was Christian Huygens in 1655 who finally solved the puzzle. Using a more advanced telescope, He proposed that Saturn was surrounded by a thin, flat ring, nowhere touching, and inclined to the ecliptic. This was one of the most significant discoveries in astronomy, expanding humanity's understanding of what planets could be. Around the same time, Huygens also discovered Titan, Saturn's largest moon, beginning the exploration of its extraordinary satellite system. Later, in 1675, Giovanni Domenico Cassini discovered the division between the A and B rings, which now bears his name, the Cassini division. He also identified several more moons, including Iapetus, Rhea, and Dione, laying the foundation for future exploration. As telescopes improved, Saturn revealed more details. Astronomers mapped its bands, tracked its storms, and studied its peculiar flattened shape, caused by its rapid rotation. Yet no matter how much they learned, the rings remained a source of fascination and mystery, their origin debated for centuries. For most of human history, Saturn was a world glimpsed only from afar. That changed in the 20th century, with the dawn of space exploration. In the late 1970s and early 1980s, the Pioneer 11, Voyager 1, and Voyager 2 spacecraft flew past Saturn, sending back the first close-up images of its rings and moons. Voyager revealed Titan's thick atmosphere and Enceladus's bright surface, raising questions that would drive future missions. But the true golden age of Saturn exploration came with the Cassini-Huygens mission, a joint project of NASA, ESA, and ESI launched in 1997. Cassini entered orbit around Saturn in 2004 and spent 13 years exploring the system in unparalleled detail. It revealed the complexity of the rings, the geysers of Enceladus, and the methane seas of Titan. In 2005, the Huygens probe detached from Cassini and descended through Titan's atmosphere, landing on its surface, the first landing ever achieved in the outer solar system. The images it sent back showed a stony, river-carved landscape, a haunting reminder that alien worlds can be eerily familiar. Cassini's mission ended in 2017 with a dramatic, grand finale, in which the spacecraft plunged into Saturn's atmosphere to ensure it would not accidentally contaminate Titan or Enceladus, both of which might harbor life. In its final moments, Cassini became part of the planet it had studied so faithfully, sending back data until the very end. Beyond science, Saturn has always inspired art, literature, and philosophy. From William Blake's mystical poems to Salvador Dali's surrealist paintings, Saturn's image, often tied to melancholy, depth, and mystery, has haunted the creative mind. In astrology, Saturn is still regarded as the planet of discipline, challenges, and mastery, a celestial taskmaster that shapes destinies. In popular culture, from science fiction novels to films, Saturn often serves as a symbol of the outer frontier, the place where human imagination meets the unknown. To humanity, Saturn has always been more than just a distant planet. It is a mirror of our fears and hopes, a clock marking the passage of time, a reminder of both beauty and impermanence. From gods and myths to telescopes and spacecraft, Saturn has journeyed with us, shaping our understanding of the universe and our place within it. Saturn is not only an object of beauty and myth, it is also a scientific treasure chest, a natural laboratory where astronomers and planetary scientists test their theories about the universe. Every ring, every storm, and every moon around Saturn holds clues about how planets form, how solar systems evolve, and whether life might exist beyond Earth. Studying Saturn is like opening a window into both the past and future of our cosmic neighborhood. One of the greatest questions in astronomy is how planets come to be. By examining Saturn's rings and moons, scientists see parallels with the early solar system itself. The rings, composed of billions of icy particles orbiting Saturn, resemble the disks of gas and dust that swirl around young stars. Within such protoplanetary disks, collisions and gravitational clumping eventually give rise to planets. Saturn's rings, then, serve as a miniature model of planetary formation, allowing scientists to study in detail the processes that shaped our own solar system over 4 billion years ago. Saturn's moons also play a critical role in this story. Many of them show evidence of tidal heating, orbital resonance, and gravitational sculpting, all of which demonstrate how complex interactions between celestial bodies drive their evolution. These lessons are vital when astronomers look beyond our solar system to the thousands of exoplanets now discovered around distant stars. The behaviors we see at Saturn may very well mirror what is happening in faraway planetary systems. Saturn's atmosphere is another rich source of scientific knowledge. Its powerful winds, hexagonal storm, and periodic great white spots demonstrate the dynamics of fluid motion on a massive scale. These atmospheric processes are governed by the same physical laws that shape weather patterns on Earth, Jupiter, and even exoplanets. By studying Saturn, scientists refine their understanding of climate, turbulence, and storm formation, knowledge that may one day help us model the atmospheres of alien worlds orbiting distant suns. Even Saturn's magnetic field provides insight. Generated by metallic hydrogen deep inside the planet, its magnetosphere captures particles and interacts with the solar wind, creating auroras. These processes help scientists understand magnetic fields across the universe, from other gas giants to entire stars. Since magnetic fields may shield planets from harmful radiation, studying Saturn's magnetism also informs the search for habitable environments beyond Earth. Perhaps the most profound scientific significance of Saturn lies in its moons, particularly Titan and Enceladus. Both moons contain ingredients essential for life: water, in liquid or ice form, organic molecules, and sources of energy. Titan, with its methane seas and complex atmospheric chemistry, is a natural laboratory for studying prebiotic chemistry. It may resemble conditions on early Earth before life emerged, offering a chance to explore how organic molecules evolve into living systems. Enceladus, with its subsurface ocean and hydrothermal activity, presents an even more direct possibility. Its plumes contain salts, water vapor, and simple organics, creating an environment strikingly similar to Earth's deep-sea vents, where life thrives in the absence of sunlight. The discovery of such worlds within our own solar system profoundly impacts the search for extraterrestrial life. It suggests that habitable environments may not be rare, but instead common on icy moons orbiting gas giants, whether around Saturn, Jupiter, or even planets in other star systems. The study of Saturn has also illuminated our understanding of exoplanets, planets orbiting stars beyond our Sun. Many of these distant worlds are hot Jupiters or mini Neptunes, giant planets with thick atmospheres and possibly rings of their own. Saturn provides a nearby example of what such planets might look like under different conditions. The discovery of Saturn-like exoplanets with ring systems, such as J1407b, sometimes called the Super Saturn, shows just how relevant Saturn is to the broader search for worlds across the galaxy. Saturn's unique features, its low density, its complex system of rings and moons, and its atmospheric dynamics, give scientists models to compare with these distant giants. By studying Saturn, we do not just learn about our solar system. We also sharpen our tools for understanding the thousands of alien worlds being discovered every year. Though Cassini ended its mission in 2017, Saturn remains a target for future exploration. Proposals for new missions include orbiters dedicated to Titan, landers or submarines to explore its methane seas, and probes that could dive into Enceladus's plumes searching for direct evidence of microbial life. One such mission, Dragonfly, is already approved, a nuclear-powered drone-like craft that will fly across Titan's surface in the 2030s, studying its chemistry and geology. Dragonfly represents the next leap in our exploration of Saturn's system. If successful, it may help answer some of the most profound questions in science. How does life begin? Can it exist elsewhere? And if so, might it already be thriving in the hidden oceans of Saturn's moons? Saturn is far more than a distant gas giant. It is a key to the origins of planets, a guide to the workings of atmospheres, a clue to the mystery of life, and a mirror for exoplanets far beyond our reach. To study Saturn is to study the universe itself. From the moment our ancestors lifted their eyes to the night sky, Saturn has inspired awe, curiosity, and wonder. Unlike the countless stars that twinkled in the heavens, Saturn stood apart. Its golden glow and steady brilliance caught attention, and when ancient astronomers first peered through primitive telescopes, they saw a planet unlike any other, surrounded by rings that seemed almost divine in their perfection. To this day, Saturn remains one of the most breathtaking sights in the cosmos, a reminder that nature often creates beauty alongside power. For thousands of years, Saturn has carried symbolic weight in human culture. In mythology, Saturn, or Cronus in Greek tradition, was the ruler of time, harvest, and destiny. This association with cycles and eternity mirrors the planet itself, whose slow orbit around the Sun takes nearly 30 Earth years. Saturn's immense rings, forever circling it, evoke the passage of time, the cycles of nature, and the boundless energy of the universe. When we gaze at Saturn, we are not merely observing a planet. We are engaging with a timeless emblem of cosmic rhythm. Saturn's rings, delicate yet vast, remind us of fragility and strength. They stretch across hundreds of thousands of kilometers, yet their thickness in most places is less than a kilometer. This balance of enormity and thinness, majesty and vulnerability, is a reflection of the cosmos itself, grand, expansive, yet fragile and interconnected. What makes Saturn so extraordinary is that it bridges the realms of imagination and science. Artists, poets, and dreamers look upon it and find beauty, while scientists see a natural laboratory filled with answers to some of the deepest mysteries of existence. Saturn proves that the two perspectives are not in opposition, but rather complementary. It is a planet that demands both emotion and intellect, both heart and mind. When Cassini plunged into Saturn in 2017, ending its mission, many on Earth felt a sense of loss. It was as if we were saying goodbye to a companion, a distant world that had shared its secrets with us. Yet the legacy of Cassini and the countless discoveries that Saturn has given ensure that the planet remains alive in our collective memory. The data continues to fuel new insights, inspiring future generations of explorers. Saturn also represents humanity's eternal quest to go beyond what we know. Every mission that has journeyed toward it, Pioneer, Voyager, Cassini, has been a testament to our hunger to explore. Each moon, each storm, each ring reveals not just the mysteries of Saturn, but also the deeper truth that the universe is vast, interconnected, and waiting to be understood. One day, humanity may send explorers not just to orbit Saturn, but to walk on Titan's orange plains, to dive into Enceladus's geysers, or to float through its rings. Such journeys, whether robotic or human, will bring us closer to understanding not only Saturn, but our own place in the cosmos. In the end, Saturn is more than a planet. It is a mirror for the universe, a stage upon which the drama of cosmic creation unfolds. It is a symbol of time, beauty, fragility, and endurance. It teaches us about how worlds form, how atmospheres swirl, how oceans may hide beneath icy shells, and how life might take root in places we never imagined. When we gaze at Saturn, we are not just looking outward. We are also looking inward, into the depths of human curiosity and the eternal drive to seek answers. Saturn will continue to inspire long after our lifetimes, reminding us that exploration is not simply about reaching new places, but about expanding the horizons of the human spirit. Saturn is not only the jewel of our solar system, it is a beacon of science, of mystery, of beauty, and of endless possibility.